In this video, we're going to go over some problems that are like the ones you'll find in the Ready, Set, Go sections that follow task 5.4. So in the Ready, you'll be writing an equation of the line. One way that you can write the equation of a line is to use slope-intercept form. For this, you'll need the slope and a y-intercept. So if your slope is 1/2 and your y-intercept is 0, -5, all you need to do is substitute 1/2 in for m and -5 in for b. Remember that if the y-intercept, x is always going to be 0. b represents the value of the y and the y-intercept, so you substitute -5 in for b. When you're given a line, like in question 5, you need to find the slope and you need to find the y-intercept from the line. To find the slope, we want the change in y over the change in x. You can see it's going up 1 to the right 1. So the slope is 1, and the line crosses the y-axis at 0, 3, so the y-intercept is 0, 3. So the equation of this line is y equals 1x plus 3. Now let's find a line that is parallel to this line but passes through the point 2, 2. So we have our point 2, 2 that's being graphed, and now we're just going to use our slope to go up 1 and over 1, up 1 and over 1, just like our other line. And we'll draw the line that goes through the points from using the slope and through our given point. So here, this red line, you notice if we follow it, it crosses the y-axis at 0, 0. So that means our equation is y equals 1x, so it has the same slope, but our new y-intercept is 0. Verifying and justifying geometric relationships. So let's compare the length of BC and DC. One way to find the length of a segment is by using the Pythagorean theorem. So for BC, if we create a right triangle, we can find that the height of the right triangle is 3 and the length is 4. So if we use Pythagorean theorem, a squared plus b squared, we can substitute in the 3 and the 4 and then solve for c, and we can find that BC equals 5 units. It's 5 units long. DC is also 5 units long. So we can see that BC, the length BC, is equal to the length DC. In order to determine if the lines are perpendicular, you're going to need to find the slopes of both lines or line segments and compare to see if they are opposite reciprocals. So let's take a look at the slope of AC. The slope of AC, we go down 6 and to the right 3. So the slope is -2. And then if we want to find the slope of BD, we're going up 2 and to the right 4. So that slope is 1 over 2. Now when we compare the slopes, we see that the slope of AC is -2 over 1, where the slope of BD is 1 over 2. Those are opposite reciprocals. And so we know that they are perpendicular. So segment AC is perpendicular to segment BD. Now we're going to look at the Go, where we're going to write equations of parallel and perpendicular lines. Let's consider this table and try to write the equation of a line that is perpendicular to it that goes through the point 4, -5. So first, let's check out our y-intercept. Remember, x is 0 and a y-intercept, so we know that the value of b will be -8. Now let's take a look at the slope. So the change in y is -8 when the change in x is +2. So that means the slope will be -8 over 2, which equals -4, and we can substitute -4 in for m. So the equation of this table, the function that's represented in this table, is y equals -4x plus -8. Now we want to find an equation of a line that is perpendicular and passes through the point 4, -5. So we'll use our point slope form of a linear equation. And we have our point 4, -5, and our perpendicular slope, which will be positive 1 over 4. We just have to substitute in these values, and we have an equation that's written in point-slope form. If we want our equation in slope-intercept form, we just have to simplify. To simplify this, you just need to use the distributive property and then combine like terms. And we have y equals 1/4 x minus 6. That concludes this video. Thank you for watching.